Okay, so now we're going to do some problems that involve the inverse sine function, and I have our defining relationship up here that relates the inverse sine notation to the sine function that we already know, and just a couple examples of how this notation gets used before we start solving some problems. We know, I'm just going to pick an example that I know. Sine of, I'm going to pick an angle, say pi over 3. Sine of pi over 3 is square root of 3 over 2. That's one of our unit circle values that we have memorized, right? So we can turn this around into an inverse sine statement. We can just reverse the input and the output. So sine inverse, so what I'm going to put inside of sine inverse is the output value for sine, the trig function value, square root of 3 over 2, equals the angle, pi over 3. It's like the inverse sine function takes the value of a trig function and spits back the appropriate angle. Okay? Another example is we know sine of pi over 2, sine of 90 degrees, is 1. So we could say sine inverse of 1, the output of the sine function, equals pi over 2. Notice that there's, like when we use the regular sine function, the angle goes inside. With inverse sine, the angle's on the outside. Regular sine, the angle's inside. Inverse sine, angle's on the outside. So when I go back up to our defining relationship here, the angle is like the b here. So the b there and the b there, it helps me sometimes just to remember that that represents an angle measure. So let's go ahead and do some exercises now. And no calculator for these. You can evaluate the inverse sine function on a calculator, and we'll talk about that eventually. But right now we want to do these by hand. So number one is to evaluate. Got 3 parts to it. Sine inverse of a half. Sine, I always forget to dot my i's. Sine inverse of -1. And sine inverse of 2. So 3 parts to this. And so let's start with A, sine inverse of a half. Now, because the inverse sine expression is equal to an angle, it helps me if I say let theta equal sine inverse of a half, because the inverse sine function would spit out an angle measure. So I like to use the symbol theta to represent that. And then I rewrite this using just regular sine function. So I can say the sine of theta is equal to 1/2. And the fine print is that negative pi over 2 is less than or equal to theta is less than or equal to pi over 2. Sometimes we won't even have to make use of this information, but sometimes it's going to be critical to solving the problem. So we always got to keep in mind that restricted interval that we based our definition of inverse sine on. Now, sine of an angle is 1/2. I know sine of 30 degrees is 1/2. I know theta is pi over 6. Right here, and pi over 6 does fall within those values. And that's my answer. You can say sine inverse of a half is pi over 6. So we want sine inverse of -1. So again, I'm going to do the same thing. I'm going to let theta equal sine inverse of -1. And this allows me to rewrite this using the regular sine function. It makes it a little bit easier for me to think about the problem. So then sine of theta is equal to -1, and negative pi over 2 is less than or equal to theta is less than or equal to pi over 2. And so I need an angle here whose sine is -1. Now, if you rely on your unit circle diagram, you might want to say 3 pi over 2. It's true, sine of 3 pi over 2 is equal to -1. I can see this on my sine wave graph here. But when we apply the inverse sine function, we have to find a value of theta that falls in the restricted interval. So going back to my sine wave picture that we used for the definition, when I'm looking for the theta value, I have to look along this portion of the sine wave, the restricted portion that we use to define the inverse sine. So yeah, it's true, sine of 3 pi over 2 is -1, but for the inverse sine function, I have to find my point along this portion of the curve, so I have to use a different angle value where sine is -1. I have to use negative pi over 2, because negative pi over 2 is on that restricted interval, and sine of negative pi over 2 is -1. So theta is equal to negative pi over 2, not 3 pi over 2. Again, we're not allowed to use that value because it doesn't fall within our restricted interval. Sine inverse of -1 is negative pi over 2. And C, we want sine inverse of 2. Let's do the same thing. Let theta equal sine inverse of 2. Then we rewrite with the sine function, regular sine function, sine theta equals 2. And wait a minute here. Sine theta equals 2. The values of the sine function are always less than or equal to 1. Sine is never greater than 1. So this is impossible. There's no solution. No such value. No such angle. All right. We got a couple more problems. I guess I'll go to a new sheet here and maybe keep our relationship up there at the top. Another exercise. Find cosine of sine inverse of negative square root of 3 over 2. Whew, that's enough stuff going on there. Now, it's the output of inverse sine, the B thing, that we think of as an angle that helps us have some intuition about what's going on. So I was letting the A, B, and the C in the first exercise. This is number 2. be equal to theta. Here, it's really this quantity inside parentheses that we would want to call theta because it's the output of the inverse sine function. So to get started here, I'm going to let theta equal sine inverse of negative square root of 3 over 2. This allows me to break this problem into pieces because, you know, this cosine of sine inverse, there's too much going on there. So I'm going to let theta equal sine inverse negative square root of 3 over 2. Then, what can we say? Sine theta is equal to negative square root of 3 over 2. And negative pi over 2 is less than or equal to theta is less than or equal to pi over 2. Let's see if we can find theta. And theta won't be our answer, but theta will help us get through to the end here. Now I got to be careful with this one too. Now I might even try to draw a unit circle here. Let's think about the unit circle. I know sine of pi over 3 is square root of 3 over 2. We were just saying that a little while ago in our preparations. I'm going to just draw this in my unit circle. Here's pi over 3, or 60 degrees. The cosine is a half, so the x is a half on the unit circle. The y is square root of 3 over 2. Now we actually want the sign to be negative, and when we say theta has to be between negative pi over 2 and pi over 2 on the unit circle, that's kind of like saying 0 to pi over 2 is the first quadrant. In the negative direction, from 0 to negative pi over 2 is in quadrant 4. So that negative pi over 2 to pi over 2 is this sort of quadrant 4, quadrant 1 side of the unit circle. So I know I'm looking for an angle down here, and I know the coordinates of that point are going to be x is positive, y is negative. Pi over 3 is my reference angle for what we're looking for. Now, I don't want to do this. I don't want to pluck this angle off of my unit circle, which is 5 pi over 3, because that's not within the restricted interval of definition. So that's where we can't just pull that value off of our unit circle. What we actually want is the negative angle measured in this direction. That will fall in the interval from negative pi over 2 to pi over 2. And it's actually not hard to, by symmetry here, to just see that's negative pi over 3. So theta is equal to negative pi over 3. We have our theta value. And now we still got to finish this problem. We want, what did we want? We wanted cosine of sine inverse of negative square root of 3 over 2, which is cosine of, what we just figured out is all this stuff in here is negative pi over 3. So we want the cosine of negative pi over 3. Well, I actually already drew it in my picture here. The cosine of negative pi over 3 is going to be positive. We're in quadrant 4, and it's positive 1/2. So that's my result. Oh, sorry. Okay, there we go. I'll leave it on the screen for a bit. I got below the... Okay, we got one more we're going to do, and this is super important. Exercise 3, I want you to find cosine of sine inverse of 3/8. So it looks kind of similar to what we just did, but it's also kind of different. And again, we're going to do this by hand, no calculator to help. Now, inside these layers of things, that inverse sine value I think of as an angle. So again, I'm going to let theta equal the inverse sine of 3/8. And then translate that into a statement about sine. So sine theta, sine of the angle, equals, this is the value, 3/8, and negative pi over 2 is less than or equal to theta is less than or equal to pi over 2. Now, there's, this isn't one of our famous angles. We don't know how to find, we don't know, in fact we can't, how to find theta by hand without using a calculator. And the funny thing in this problem is we don't need theta. Because what we're trying to find, we want, for our answer, cosine of sine inverse of 3/8. Well, because I called sine inverse of 3/8 theta, we just want cosine of theta. Cosine of theta is going to be the answer to the problem. We know what sine theta is. We want to find cosine theta. We know sine theta is 3/8. We want cosine theta. And so this is an important kind of problem that I think we've seen before, but we're going to see it more and more often. We got to know how to work this by hand. And we can do it by using the most famous trig identity. Sine squared theta plus cosine squared theta equals 1. We have to pull this out of our back pocket. We've talked about how this identity can be used to find one of these two values when we know the other one. We can plug in 3/8 for sine theta, and we can solve for cosine theta. This could be 9/64 plus cosine theta squared equals 1. So cosine theta squared equals 1 minus 9/64. And so you're going to have to do 64/64 minus 9/64 is, I think that's 55/64. So cosine theta squared is 55/64. Doing this by hand. And so cosine theta, now I can take square roots, is plus or minus the square root of 55/64. And I got to make a choice now. I need to know whether to use a plus or minus sign. And in the past, we've made that decision by looking at what quadrant the angle is in. And what do we know about theta here? Well, all we know about theta is that negative pi over 2 is less than or equal to theta is less than or equal to pi over 2. That means we're in quadrant 1 or 4. This just limits us down to 2 possible quadrants, quadrant 1 or 4. And it turns out the funny thing is, in both quadrant 1 and 4, quadrant 1 or 4. In both of those, cosine is positive. So we actually, I guess we could probably figure out which one it is. We don't have to. We know that in both those quadrants, cosine is positive. So this value that we need is, we have to take the positive value, and I can take that square root of 64 is 8 in the denominator. And so positive square root of 55 over 8, which is my answer, right? Because cosine theta was our final result. I'll just sum it up here. Cosine of sine inverse of 3/8 equals square root of 55 over 8. And yeah, I'll just lift this up a bit, see if we can get the whole problem in there. Just about, yeah. 55 over 8, and that's our result. This is a really important exercise for you guys to think about. We'll do more examples like this together.